All right, good afternoon. I have the distinct pleasure of introducing, not only working with these two gentlemen, but of introducing these two gentlemen for our panel today. The panel that we have today, what we're going to do is really have a sort of a roundtable discussion and talk about some of the issues that they've seen, I've seen in third-party validation of DAS networks. Our first guest here is Nathan Cornish. He's the Director of RF Engineering for Transit Wireless. He's the leader of the RF Engineering Department. He manages the commissioning of all wireless carriers for the network. He oversees the RF design development, works with Transit Wireless's wireless customers to interface into the DAS systems. Partners with all departments. He ensures the RF system not only meets the carrier technology and cost efficiency requirements, but ensures the system operates with the highest availability for the entirety of the system's 20-year contract. Mr. Cornish previously held the position of Design Engineering Team Leader with Broadcast Australia for 5 years before being promoted to RF Engineering Manager within Transit Wireless. He served as the lead engineer for the multi-million-dollar digital radio services synchronized rollout, that's a mouthful, synchronized rollout across 5 capital cities with a focus on bid, design, implementation, and commissioning. Nathan earned his Bachelor of Engineering in Telecommunications Engineering with first-class honors and his Bachelor of Business in Finance with distinction from the University of Technology in Broadway, NSW.
New South Wales.
New South Wales, in Australia. Additionally, he was honored with the UTS Engineering Dean's List for outstanding academic results from 2002 to 2005. He received the nomination for Engineers Australia 2009 Young Engineer of the Year Award. Congratulations. And also with me, I have David Evans. He's the New York City Area Manager of DAS for AT&T. David is a seasoned and successful RF manager with over 15 years of experience leading complex technical projects, developing strategic and creative engineering solutions, and designing and improving wireless networks. At AT&T, he designed and delivered many high-profile DAS projects in New York, including MetLife Stadium for the 2014 Super Bowl, the Billie Jean King Tennis Center, the GM Building, Penn Station, Waldorf Astoria Hotel, and One World Financial Center. David has his BSEE and MSEE from New York University Polytech School of Engineering, and he's a registered professional engineer in several states. So with that, what I'd like to do is move on, if we could, a little bit here. Nathan, let's talk a little bit about transit, and if you can give us a little bit of an overview. Transit Wireless is probably one of the largest DAS systems in the world. It's complicated, it's a harsh environment. And then on top of that, as we were talking backstage, many of the things that we've talked about in today's panels, Wi-Fi and sort of the convergence, if you will.
Public safety.
Public safety, that's right. We've got the base station hotels. I mean, you guys had base station hotels from the get-go, basically. Maybe you could talk a little bit about transit and the underground, just some of those things.
Right, so Transit Wireless, if you've not obviously heard of us, is the company that owns and operates the wireless and Wi-Fi infrastructure in the New York City subway. Now, the New York City subway, as you're all very much aware of it, even an Australian knows about it, is more than 100 years old. So it was never designed for Wi-Fi or wireless services. So it's obviously been a bit of a black hole for all the carriers for a significant length of time. So we've got that contract as a neutral host provider to build out these subways, and there are 279 subways, and as you can see on the board, we've broken it into a number of different phases, and we're currently rolling through our 3rd phase and almost into our 4th phase. So this is kind of an interesting DAS system. It's not one building, it's essentially one building split over an entire city. So beyond that, there's a significant amount of infrastructure behind it, but also from a traffic standpoint, it's growing and growing. So when the build-out started, it was less than 2 billion riders a year. Now we're seeing from last year, it's up to 2.6 billion riders, and it continues to grow.
We talked about how some of the concepts earlier, the Wi-Fi and that type of thing. Your system, and let me move forward here. On your system overview, we've got a system overview slide, but one of the things here is we talked about Wi-Fi, but maybe you could talk a little bit about the architecture, but also Wi-Fi. The other thing is relative to, and we talked about this before, you sort of have two masters almost, in that you've got the MTA, and while we've talked, some of the other guests here have talked about, in building and dealing with the owners of the buildings, and while dealing with the owners of the buildings may be somewhat onerous,
Right.
I can't imagine it compares to dealing with the MTA and the policies and the procedures and the safety and that type of thing. So, but we've got Wi-Fi there, we've got commercial carriers, we've got the MTA's 4.9 system as well. So maybe you could talk a little bit about that.
Yeah, so originally, and up on the board gives you a bit of an overview of the system. It's a sort of a layered network, similar to the previous discussions. We have a base station hotel facility that leads into an outside plant fiber network and then into the stations itself. But the MTA itself was originally just, a co-revenue share with us, but now the MTA has actually moved into being one of our carriers as well. So we provide the cellular services for the carriers, and they're all building out their networks to meet that. We provide a public safety network as well in a 4.9 network. So we kind of have two SLA requirements. One is obviously to the carriers themselves for their network, but we also have an agreement with the MTA for their 4.9 Wi-Fi network.
And that's where we're talking about here. We're talking about the parallel system. The parallel systems are really the 4.9 and the Wi-Fi in parallel with the wireless carriers at that point as well. So
right.
The one question is what challenges do you have with that?
Yeah, look, someone mentioned in a previous discussion that the convergence of Wi-Fi and cellular services. So what we did as a step to reduce the amount of infrastructure in the station, which despite it being, some would say, quite an ugly system, each to their own, the MTA spends a lot of time trying to make these stations less cluttered. So we wanted to get Wi-Fi in there because it was an emerging technology. So what we did was we paralleled the two systems together. So we essentially have coax and fiber running side by side, and then we have a combined box that sits there and provides both cellular, Wi-Fi, and 4.9. So from the MPA's perspective, they're getting around the fact that we're only putting one box in the ceiling, but we're actually providing three services. So that box itself, one of the strong components of that box is the subway is a harsh environment. It's considered an outdoor environment. So the boxes that go into the station need to be outdoor rated, both in temperature and in ingress, because when I mentioned the subway, they try to keep it clean and tidy. They literally have crews of people who come through with high pressure hoses and wash the entire station down. So we need to be able to protect against that, as well as the extreme heat that I'm sure you all complain about in about 3 months' time.
Let's switch gears here for a second. This is a slide that we've got with that Transit Wireless goes through with their design approval for carriers. But Dave, maybe you could talk about this a little bit here, because obviously you're involved with this from the other side of that fence, from Nathan. So here he's got a process where he goes through and he's got various bands that are out there as part of the system, some of which you occupy, some of which you don't. How does this vary from, say, some of the buildings and some of the other big venues that you've talked about? What are some of the similarities and what are some of the differences and relative to the design approval process?
So AT&T is a tenant on the system, and we do have some input as to what the design looks like. And ultimately, the design has to meet our needs, our requirements. The question was, how is it different from some of the buildings or other venues that we design? All of these stations are underground, so we don't have to deal with macro penetration into the stations in the same way we would have to deal with that in an office building.
The ingress and egress problem.
We do have ingress and egress.
It's different though.
It's different. So in an office building on the 10th floor,
We've got
we would have to
blown in the
compete. We'd have to
windows.
have a system that can compete with macro
Right.
penetration, and we have to ensure that we're able to do that successfully. The design review process would be pretty much the same. So we would look at something, well, we would get something like this from Nathan. This would be typical to show us what kind of signal levels we can expect from the antenna system under consideration. And what we would do is we would evaluate it to make sure that we can get our minimum requirements for throughput and coverage. And capacity does come into play, but most of these stations are relatively small compared to, say, an office building, which is going to have a few thousand people in it. The station's going to have a few hundred people in it at any particular time. Not a gigantic station, but a normal size station. So we would review all this material. We would make sure the bands that are intended for use by us, the amplifiers and the bands on the side there, that there's enough power available to us, and the amount of spectrum we want to deploy is going. We're going to have enough power for the amount of spectrum that we want to deploy. So we would go through that and give feedback to Transit Wireless.
Now, the title of this and the emphasis of this presentation is really third party. Third party help come in at this point here, or?
It may, because we may want to do an evaluation of the ingress-egress signals, as you alluded to earlier. The stairwells leading in and out of the stations are important for us, and you'd be surprised at how much the macro signals can penetrate sometimes, and there are street gratings as well where that can happen. So
Right.
we do surveys on occasion, and we would want to use a third party to do that kind of survey for us. We don't really have the resources, and when we do, it actually makes sense to do it with a third party anyway.
Well, especially in this environment, because you've got safety training issues, you've got just a whole host of issues that you maybe wouldn't have, say, in a building.
Right, and there may be some economies of scale that could be capitalized on for a third party to then collect benchmark data for not just AT&T, but for any other operator who we're interested in seeing that kind of measurement.
Okay, and Nathan, maybe you could talk a little bit about the design approval process and what you go through internally.
Yeah, so
with Dave.
Yeah,
and
well,
the other carriers.
there's Dave, there's the other carriers, but unlike most buildings, we also have a very strong owner-occupier, essentially, in the MTA. So before we get to this stage, we actually go through a full approval process with the MTA. So generally, we've actually got to the point, by the time we get to giving Dave the approval for this, it is what it is. So there may be an antenna that's in the wrong spot, but that's because of the fact that the MTA hasn't approved it. Now, this may be different to other venues Dave has, where the onus is on ourselves. Dave doesn't actually need to approve this design, because if it doesn't meet our SLA requirements, we have to fix it anyway. So,
and we're going to get into the SLAs in a few minutes.
Exactly.
Too, but,
So the design approval is there. At this point, it's an information base because of the fact that we've done so many of these, and Dave's guys are quite comfortable. But the initial 6 stations, I'm sure there's a lot more due diligence done on.
There was more due diligence and more back and forth.
Right.
the implementation process, now this is what you've outlined as your implementation process for Transit Wireless. Construction, the CW testing, carrier integration, and the CMRS, or the commercial testing. Now this is where, when we're talking about third-party validation, this is where the third-party validation really starts to come into play. And maybe we can talk about some of these, but, and the question really is, what value does it bring to you, to Transit, and to both of your masters, if you will, to the MTA and to, say, the wireless carriers? Right.
So obviously there's a number of stages in construction similar to any other building. The first step of construction is actually validating the installation. And generally that is done by the construction company that does it, but we also bring in third parties such as V-COMM at that stage to, they validate that the people actually doing the work know how to use the test gear, are certified in using the test gear. actually understand the results, and they're providing the results we need. So we don't have the resources to be out there every night of the week, and generally Transit Wireless and all our subcontractors are building every single night of the week from 9 p.m. through to 6 a.m. So having a third party that does this regularly and can spot check at that point really helps.
So the third party here then is, I mean, there's the validation component to this. So I know, like, we've done some of this for you, and I know you've had other firms do it as well. But we come in and we'll do like the CW testing, and we've done some of the commercial mobile testing as well. And like you said, we've also worked with, and we'll get into that as far as the construction validation, that type of thing. But so there's a validation component, but then there's also just a resource component as well.
Right.
So it's more than just validation.
It's more than just validating, because you can have an engineering team that does a particular project very well, and is used to doing it. It's when you get beyond the normal, it's no point having that resource in your team if you can rely on a third party to provide you that input.
Now, Dave, here the question for you here is, and Nathan had mentioned, we're going to go through this in a few minutes about the SLAs, and I don't know that some of these building installations that you have, some may not, but specifically I know in the subways there are SLAs. So how does having this process and this carrier approval process that they go through, and the fact that they use third parties, how does that help AT&T from a decision-making standpoint, from a just an operating standpoint? How does that help you? What value does it bring?
So we have our resource constraints also, which Nathan mentioned, and there are the phased projects are 39 stations each, the latest ones anyway, and it's we just don't have the resources internally to be able to do that much work when these stations are ready to come on. Everything has to happen simultaneously, so that's definitely a factor. But there's also a lot of equipment that we need to have tested that the AT&T doesn't own. So there's a lot of shared equipment. We do want to ensure that it's working, but it's equipment that's shared amongst the carriers, all the operators, all the wireless service providers, and we actually prefer to have somebody who's a third party looking at that with an objective overall view to make sure everything is working for everybody, and we feel that there's value there. We do our own functionality testing as well, but we like to see a thorough third-party analysis to make sure everything is working the way that it's designed to work.
Sort of a sanity check from your perspective. One of them is a sanity check to the other one, basically.
Exactly.
Right. Okay. Now, on this next slide, again, this is Nathan, this is one of your slides, the propagation model. We'll spend a minute on this, but basically, and you can see here on the slide, what we've done is we've gotten, there was the RF prediction, and then we did some field measurements for you. Let's talk about the kinds of problems and issues at that stage that we've found and actually been able to correct, and how helpful this was in the value. And there's another question I'll have after that. Right.
So it's similar to normal buildings. There's a CW process that's done to establish the building itself. The subway itself, we've now done more than 100 subway stations, so we generally know what the walls are going to do. So we don't walk out there and test every single station to see what the propagation's like, right, because it's the same as the last one. But what we've done here is we've outsourced to V-COMM in this standing is there's a certain effect that we see in the subway, we don't understand it. So we've done our own modelling, we've given that modelling to you, and you've gone out and validated how close our modelling was to the reality. So, having that resource to take, it would have required my engineers to go out there in the field and do this, and if you may have picked up our roll-ups quite quick, doing something like this properly takes more than a few hours in the field. It takes preparation and then it takes documentation. So giving that to a third party who does it well just keeps my designers designing.
And from a design standpoint then, this can help you, and like you said, in the subways, I mean, use IBWave. IBWave is an excellent tool and it works well, but these subways are 100 years old.
Right.
You've got plans. I remember looking at one of these with you with a tunnel recently that The drawings were from 1939, I think, or
Right.
some from way back. And so the ability to capture all of that and then get that properly into IBWave so it can do what it needs to do is difficult.
Right.
So in this particular case, I mean, here, so basically what you're saying is over and under prediction that IBWave is doing because you just don't have enough information about them.
Right, and this is someone in my team has coined the wall effect, but essentially you can, if you want to get into the details, you can see that there are a bunch of I-beams running along and IBWave predicts it as it's just going to go straight through it. But through this testing ourselves, we can see that it creates a sort of a steel structure that the propagations won't go through.
Right. And then we talked a little bit about, we'll touch on this for a second, but the CW testing, the carrier wave testing. In these cases here, when you've done this, and my recollection when we've worked with you on these things are a couple things, besides actually testing to verify that everything's working properly. You also use it to help with power distribution, adjustments to the system, that type of thing, so that, again, you did the modeling on the last slide. Really, it's to fine-tune the system so that when you're ready to bring on an AT&T, you're pretty confident that the system works.
Yeah, so this is a big project, and it's a big project for the carriers. So what you can see here is the CW testing that we've done once we've built the system out, which is common to any DAS distributor. The difference is here that this is a sign-off that we provide to the carriers that they're happy that it meets the model. But more than that, for us, this helps us identify ahead of time, based on historic, if there's going to be any issues for the carriers that we need to fix at this time. This doesn't show it in this slide specifically, but I think if we go to the next one, you'll see that what we've got here is this is an issue that CW has identified for us using the third-party testing. Up the top is red's not good, as opposed to AT&T liking red. I say red's a bad thing, so red is bad over here. On the side is the IBWave prediction, and having our testing done ahead of the carriers getting involved has demonstrated to us that our construction company has actually made a major issue with the couplers and the splitters. So having V-COMM come in, they did the testing, they've given us feedback and said, hey, hang on, this one's an obvious one, but look, there's something wrong here, you guys need to go resolve it. And so that gives us the ability to go back to our construction company, resolve it, retest it, and then provide, the only thing AT&T would have seen in this is that final result. So they don't need to know that there's issues along the way because they've got a lot of issues they're dealing with themselves. They're paying us to get it done. They don't want to see issues. So
the two things that you had mentioned here then, and I'm going to ask you a question, Dave. You had mentioned, well, one, I mean, obviously this gives you the ability to, you've got your SLAs and it's your sort of first sign-off with the carriers, but it also gives you the ability then to really hold your contractors' feet to the fire because you can't just keep going down there and sending people back.
So I guess just to break in, as a result of this, we actually, it gave us the ability to go back to and we'll get to this later on, go back to our contractors and go, hang on, this is a major issue, how can this happen? And it turns out their knowledge of the system wasn't good enough, so it encouraged us to go back and retrain them, essentially.
Right. And then Dave, for AT&T at that point to see, and what Nathan's described here is you didn't see the first one,
Right.
which frankly I
He
would
does
imagine.
now, he's a bit concerned.
No, well, actually, we need to know that this is going on.
Right.
So we don't need to see the details necessarily, but we do need to know that due diligence is done. We do not want to turn on a system for commercial service and then go out there and find half the station doesn't work when we're testing it. We want to have confidence that it's going to work on the day that we turn it on.
Especially with 7 million passengers a day.
Exactly.
Right.
One of the biggest things your team deals with is this doesn't have a downtime, it's live.
Yeah.
And so if you come in and I give you issues, you have issues from day one.
Yeah, we don't want to see that. Everything's got to be tested uplink and downlink in these stations. We don't want to see, if you see just walk test and it looks green, you go there and you have no uplink. We need to have a level of confidence that we're not going to find that situation.
And in the testing here with transit, it's both uplink and downlink. So the uplink is a more difficult test to perform.
Yeah.
The downlink is pretty, not simple, but The
It's
uplink
easier.
requires a little more ingenuity to get that thing going. Now, on the metrics testing here, this is where absolutely third party comes in here. And in fact, I know we've done it for you, but you've had other firms as well. You've got other firms that have done this for you. But and these are the standard metrics for throughput, RSRP, RSCP, that type of thing. Let's jump back a little bit to the Wi-Fi and 4.9 and some of your requirements there. And then, Dave, what I need you to talk about is maybe just, again, some of the value here that you would see.
So I guess similar to these are obviously carrier metrics that I hope majority of you are quite familiar with. We have similar metrics for our public safety and Wi-Fi systems. So we have negotiated these agreements with the MTA and essentially ourselves for our Wi-Fi. But we also have to demonstrate ourselves before we make it live.
And Dave, at this point here, what happens is these are some of the reports that you see coming from Nathan. So, I mean, from transit. So he's got, I mean, as you know, and you already know the process and you've seen the process, but as we've walked through it here, I would assume at this point you've got a pretty good feeling that the system is actually working as you require it to work under your SLA.
I would say so, yeah. But ultimately, what we will do is, these are great, but once we go live, we're going to get our stats from our network, and we can see exactly how it's operating. We're going to see what kind of signals we're getting into the system, and we're going to see if there's dropped calls and things that
Right,
on the downlink
right.
as well. But it's really critical that this work be done before we turn it on.
Right.
So.
And then we've already touched on the SLAs a bunch here. Let me just move on.
Yeah, I think, well, just to talk quickly on that, the advantage of having a third party work through the SLA agreements, which we rely on V-COMM, is the third parties deal with the carriers every day of the week. So they know what sort of SLAs they're looking for. So, you know, you may, as a neutral host, have relationships with carriers, but the third parties deal with them every day of the week, so they have an understanding of what's required.
Now, this is just some, in fact, we'll move on here in the interest of time, but this is just some more of the testing here. And Dave, what we could do is we could talk about some of your testing, and this sort of fits in with, in your couple slides that you have where you talk about some of your design requirements.
Okay.
Nathan, you had talked about contractor training, and I know that we've worked with you, and you know that other firms have worked with you as well. It's a different set of contractors in the subway. It's a
Right.
different requirements, different safety, it's just different. It's not, in fact, you found that. It's not the contractors you might use otherwise.
Yeah, look, I mentioned to someone at lunch, you know, you may have picked up I'm not American, I'm from Australia. My background is broadcast, where we get a fine tune out and tune everything up. We moved to New York Subway, where we have to use electrical contracts to install RF. I would like not to do that, but that's the requirement. So the way that we've gauged that is we make sure third-party training houses have actually come in and certified those workers before they touch it, because otherwise we end up with headaches. It's built, the contractors don't know it doesn't work, and so on. So
the training is on an electrical, these electrical contractors typically wouldn't have this training, but sweep testing, PIM testing, that type of thing. And then I guess the question is in that particular case, overall the results are probably good, but I'm sure there's been some mixed things.
yeah, look, we've trained, we have a number of different contractors, and some of them have picked up on it well and some of them haven't. So the ones that haven't have either decided to go that extra training, or they've decided that this relationship doesn't work. But you know, ensuring that you train the installation teams correctly is very critical, because they're the ones who are out there doing it.
Now, Dave, you would have a similar problem in the buildings. One of the comments here on the bottom of the slide, it says a quality assurance program is a must to reduce the expensive rework. Now, for you down in the subways, it's very expensive to send one back, but you've got similar issues here.
It's expensive no matter what.
It's expensive no matter what. You and I were talking at lunch, just changing out antennas, and you'd think maybe it's easier in the building, but the problem is the buildings in New York are all pretty full most of the time. So it's easier said than done.
It's absolutely critical that we get a contractor who knows how to work with the material. And there are examples where that hasn't happened. 100%, and we've had to go back and fix things, and it's always a big problem because once a site goes into service and it's available to the public, it's a site that we can't simply shut off and fix things. So it becomes a real problem, and we really need to make sure that this is handled properly before, during the construction, and not not fixed afterwards.
Now, on this slide here, this is just some of the
Just some of the training
some
that
of
you
the
guys
training,
have
some of the
done.
slides, right?
Yeah.
EMF testing also, we've done EMF testing. One of the issues that you have, Nathan, specifically is sometimes these antennas are they're very close, right? Especially if you've got tall people down there. So EMF testing is an issue. Well, obviously, that's a third-party thing for you as well.
Yeah, you shouldn't. Doing that yourself is not the right approach because there's liabilities that are involved.
Right. Now, Dave, let's talk a little bit about AT&T Wireless. Your license in New York, and your areas in New York City, you've got 700, 850, 1900, and 2300. Now, we talked about this. So the other thing is about half the time you're a neutral host tenant, the other half the time you're a neutral host operator. So you're on both sides of that fence as well.
That's right. So when we're approaching like a greenfield project, we usually look to do a full neutral host design, which means we can accommodate another carrier. And in that regard, we're like a tower company, and we market the asset and try to get a tenant on board. But if we're joining a third-party system, then it becomes about evaluating to make sure that our needs are met, and that we're joining a system that we're spending shareholder money on that's going to make sense for us.
So we are the neutral host. I mean, you as a carrier or an operator, you've got specific frequency bands. Now you as a neutral host, you've got to open that up to bands that you wouldn't normally operate, but now you've got to operate and make available because some of your tenants
Need them.
Right, exactly. Now, and then you could talk a little bit about the design approach. Now, without going down through all these things, the interesting thing about this is when we talk about there's sort of internal and I'll call third party or external, and you see about halfway down the list here is where the external really starts to come into play. And maybe you could talk a little bit about that.
Sure. So starting at the top, it's an overview of the project. The design summary information, maybe we would send somebody some information about what we're looking for. We would evaluate the venue capacity to determine how much capacity we would like to deploy, and that drives our BTS dimensioning. It may drive the design scope if there are a lot of zones required in a stadium, for instance. But at some point, we get to where we need to do survey work, benchmarking, and understand what is the actual problem that we have to overcome with the DAS. And at that point, you can see we bring on a third party, usually.
And I'm going to keep moving through these. We're running out of time quickly here. And you and I have talked a little bit about this one here, the sectorization plan. This is where it's both inside and outside work. So your guys will figure out, this is what we need, we think, for traffic distribution, but then you need someone else to really figure out how to implement it, or that's what you use a third party for.
Well, there may not be enough information in the drawings that we have. There may be sector boundaries that make more sense, where the walls are located or where there are architectural features. So we look for third party to maybe guide us with that as well.
And we've talked about a lot of these already. Let me move to this was an interesting discussion that we had, the empty floor plans. Maybe you could talk a little bit about empty floor plans, and I'm sure a lot of people in the audience here can relate to that.
Okay, so typically we see this in an office tower in Manhattan. The owner will give us drawings that show the core of the building, the elevator, banks, and then the walls, the curtain walls of the building or the windows. But none of the tenant space is shown in the drawings. We don't know where the offices are, where the break room is, or where the cubicle walls are. And we have to move forward with a design because we have a project that we have to move.
And you know that these walls are coming, you just don't know where.
We just don't know where.
And how many, right?
So we've done some evaluation on some of the projects that have come on the air, and what we really like to do is make sure we have extra RSCP or RSSI built into the design to overcome anything that we can't predict with empty floor plans. So we want to budget in extra power, basically.
Okay. And here we've talked a little bit about this too. This is where you've got same building, alternate designs.
Alternate design.
Yeah, I think that's an interesting, if you can talk a little bit about that.
So this is a hotel.
This is your ingress-egress issue, or it can be the ingress-egress
Can
issue.
be. It can be. This happens to be a floor that's a little above the ground, but we were concerned about the initial design on the right, showing that we weren't going to have enough signal strength near the windows, and we did a revision. I think we increased the power in the remotes for this as well. We moved the antennas outside of walls, and we revised the design based on our benchmark data.
And you're saying there, in this case here, oftentimes you'll go to a third party to sort of get an outside view as to how different ways to do this and different ideas.
Absolutely.
Kind of like the sanity check that we talked about before.
It's always good to get that.
Right, right. We've talked about this a bunch already. I'm going to move on to the next one. These are just some design solutions that you've given me. And the interesting one is the one up on the left with the two antennas. Now, the question is, are they two antennas, two bands? Is that diversity? Why do we have two antennas in that picture?
That is I'm not even sure where that is, quite honestly. But it's not two antennas, two bands. This is a full two-sector deployment, it looks like.
Oh, okay, okay. And I see the other ones. You can see the picture to the right of it. You can see the two-sector antennas sort of angled a little bit.
Yeah.
And then you can see that entrance there to that stadium or whatever it is there, the arena.
Yeah. But these are just typical antennas that we would use.
Now we've got a couple more minutes here and I want to get into questions. So really we've talked about this, the third-party discussion. Nathan, you've got contractual requirements with the MTA. Mm-hmm. And we've talked about that. You've got contractual requirements with the carriers like AT&T. And then in this case, you've used V-COMM, and I know you've used other third parties as well. Mm-hmm. And Dave, you are, as AT&T, you're both a tenant and you're an operator of a neutral host. And then you operate, we've talked about that a little bit too, you operate your independent DAS system. Sometimes, like an enterprise situation when you're building for a particular customer might be, just unique to AT&T at that point.
Yeah.
I guess on each of these, really the whole thing is bringing back, and I think we've talked about this, bringing back the value that the third-party validation is, the sanity check, in this case here, the SLAs,
I think it's a resource. It is independent, which is obviously good for the two parties to be independent, but also it's a resource that is consistent and repeatable. So you can grab this resource as part of the project plan and bring it in and out. If you were to do that internally, you have a lot of people sitting around waiting for the project to finish. It's not a good way to use resourcing. You do pay obviously a little bit more, but in the long run you get a better quality product and you get a more timely product.
Okay.
One of the other ways that a third party can actually help us is if we're dealing with like an interference problem on a system, especially if either us or one of our competitors owns it. A third party can bring somebody to the table who's neutral, who doesn't have any self-interest.
Right.
Perceived self-interest, and I have found that to be helpful, actually, to use third party in that situation.
Good, good. We are just about out of time here. I want to open up the floor to questions. Well, we've got a couple right down.
You're right there.
Gentlemen, thank you for the presentation. I want to kind of focus in on the training aspect. I'm a contractor here in New York City, and I, like you, need that resource for training. So I'm wondering, my question is really, is there an independent resource?
I have a card I can give you afterwards.
For training? Do you provide the training? I mean, I know we have a lot of manufacturer training, and I'm appealing to Bixby for training for cellular, physical hands-on for technicians and installers. And that's an uphill battle so far, but where do you go for your training? I mean, at Transit Wireless, where did you go?
I guess one thing that we've created, we obviously send, if we have Inritsu gear or if we have another manufacturer, we send them out for that certification, and that's a requirement. You should definitely do that. What we did was, you saw it's in phases. So what we do is we get the contractor for that phase, and we usually end up paying them for their time. We bring them into our facility. V-COMM kind of provides certain input. They do the RF component on the generals, but we grab the suppliers. So if we're using RFS connectors or spinners connectors, we get them in. We're buying enough of them. They need to demonstrate, because not only is it beneficial for the contractors, it's beneficial for the suppliers to know that their products are being put in properly, because at the end of the day, they get finger pointed at. So it's about, we try to set up a day or two where you bring them in, you get the experts that know what they're doing, and you get them in a room and you just certify them through that process.
So it's kind of like a multi-vendor training seminar that you're conducting, and in this case, you're going through V-COMM?
Exactly. V-COMM does the kind of the RF testing and certification. Then we have our fiber provider demonstrating the splicing process and testing, just to make sure everyone is on the same page. The prep work saves the time in the long run. I guess a good example, let's say an RF component, a coupler and antenna costs $200. For me to install that probably costs $5,000. For me to replace it, if it's not working, it probably costs $20,000 or $30,000. So spending that time up front, it pays for itself, essentially.
Very quickly. In fact, we've seen, even where we've done the training and it doesn't always stick. It's oftentimes it's at a different level than some of these electricians are used to. They just haven't worked in that environment. It's not their bailiwick. And where we've run into problems, we've still had to go correct.
Yeah, so I've actually, on top of paying, say, V-COMM to be at the training, I've paid V-COMM 2 or 3 days on top of that to be out there with the contractors just to reinforce it. So in 3 weeks' time, get out there for a night. It's a quality assurance that you need to have.
One follow-up question, really on a totally different spectrum on a technical end. What does it take from an aggregate bandwidth perspective to support 7.5 million people on their cell phones? What is your pipe?
So that's Dave covering.
So we're deploying the same spectrum that we use on the macro network inside the subway station, but it's basically a distributed architecture in the same way that a cell phone network is. For AT&T, each subway station has its own cell site dedicated to it.
Its own cell site.
Right, the base station hotels, and we didn't spend a lot of time on that, but you had heard in the previous panel about base station hotels.
Right.
The base station hotels that Transit Wireless has are several and are very, very large. If you've been in there, they are large, effectively data centers, and as David had said, the carriers have multiple, either small cells, BTSs, Bs, multiple. Usually each carrier's got several racks of equipment, so.
Our base station hotels typically hold 60 sectors for every single carrier, for every single technology. So they all bring their own backhaul, and this gets back to the base station hotel discussion, but having a base station hotel means they can pool all their assets into one spot, means they can save on their backhaul costs, and it's not even so much save it, it's easier to get backhaul to one place than to 279.
Yeah.
Well, they bring it to you,
Yeah,
and then
we
you
deal
bring
with
it
that
to the
because
other.
we take the
Right.
fiber to that location.
Any other questions? Yes, in the back we have one.
Said I'd do it.
I think we're out of time, too.
Thanks a lot. The question is, how do you plan to maintain this network in terms of radio performance and maintaining those KPIs and SLAs over time as the network changes, as the subways, new walls are built or whatever? How are you going to be sure this thing's still working the same way in year 2, year 5, and moving out?
Well, that's interesting, actually. We had this conversation the other day. You've got your whole operations crew that basically maintains and keeps an eye on the network. But then, actually, Nathan and I had this conversation the other day about maybe annual checks beyond that to verify they're within the SLAs, that type of thing. And just for your own performance to confirm your own, sort of the front steps that we talked about, sort of coming back and just verifying it's working the way it was designed and intended to.
The carriers have their own monitoring, and they will tell you if it's not working, but you don't want to get to that point. So what we do is we currently, and we're still in the build process, but we go out there and do spot checks, etc. But like we're saying, we're looking at maybe a third party to come in after it and annually come back and